Hello and welcome back to my workbench. It is time once again to try to fix something, and today on the workbench I have another PS5 that is not well, and I think this one is actually a no power. Let's just see how no power it is. Yep, I did not notice a power supply starting up. We'll leave that on and give this a chance to turn on. No. We may have an actual, honest to goodness, no power. Let's get the side plate off. And with the side plate off, yes, the factory seal is in place. Excellent. All right, well, our power supply is out, and I have installed one of my spare 400 ADP 400 DRs, I believe it is. Let's just see if that will bring this back to life. Okay. No? Oh. Didn't quite connect it. How about now? No light, no fan spin. Okay. We have two different problems in here. We have a dead power supply and a problem on the main board. And this thing was sealed, completely sealed, and never been touched. Okay. Well, that's disappointing. Okay. I guess we should probably start on the main board. I wonder if this is going to be lightning damage. Lightning that has come through the HDMI port. Like if we happen to have a bad HDMI encoder, and we probably will have damage on this power supply. Well, we know it's dead, but I'm guessing it'll look like lightning damage. Okay, let's get this main board out over here, I guess, and we will start with that. Well, before I pull this board out of the chassis here, get it all broken out, I'd like to take a quick look into this HDMI port right here, just to see what our diode readings are. Trying to see if my guess is correct about the lightning coming in that way. So red probe on ground, I'm in diode mode. Pin 1. Well, let me make sure to get the board in the shot here, so you can see what I'm doing. There's pin 1, 2, that's ground, 3, 4, 5, 6. That all looks good so far. 7, 8 ground, 9, 10, 11. All the data lines, for the differential pairs, those all look good. Now we get into our signals. The control signals, I should say. Yeah, 13. 13 shows a dead short. That's not normal. Should be like 6/10, 7/10 of a volt. Okay. 14, no connection. 15, 16, 17 is ground. 18 and 19. Okay, so just 13. Okay. So, yeah, it is looking likely that we've had some lightning damage on this port. All right. I'll go ahead and we'll get it out on the workbench. All right, let's take a look under the microscope at this area around this HDMI encoder. Give that a quick check just to confirm our suspicions. And where I usually check is on these two capacitors. You know, the way I've got the board here, here's the HDMI port right here. So with that, you know, with it oriented this way, these capacitors on the corner are on the two rails that go into this chip. So it's a good place to check. And I am in diode mode. And if I check this here, red probe on ground, yeah, 0.002. Okay, and this one, 0.23. It's not shorted, but this one is. So, and we have a short on pin 13, I believe it was, which is going to be one of these diodes over here possibly. But of course, it does go, you know, the signal on pin 13 does go on into the chip here, so it could be there too. That's 0.6. Where is that signal? Oh, right there. I believe that's pin 13 going in there. And I don't see a diode there unless it's on the other side of the board. I'm not sure. I have to check, see if pin 13 has a protection diode on it or not. I don't remember. Because we're on the other side of the board. I just can't remember which signal it's on. Don't remember. This one right here. Is it that one? No, not that one. So, but we need an HDMI encoder. So that's where we will start. I do have some new ones on hand, so we will use one of those. Alright, well, our HDMI encoder has been swapped out. Let's see if that's going to get this thing running again. I do have my spare power supply in there. There we go. Should do a system storage check. Or it could just come right up. Maybe it failed while it was off. Okay. We are working though. So with that, we can turn our attention to this power supply. All right, it's time to dive into this power supply and see if we can make it work again so I can keep my spare. And I guess I should start off with removing the antenna. And this is where I mention to you also, please do not open up your power supplies as there are dangerous voltages inside that could hurt you or kill you. And no one wants that. But sometimes danger is my middle name. No, not really. I've been working on these things for quite some time. And we're in. What is that? Like some kind of a liquid in there. Shiny. I don't know what that is. Okay. Where to start? Where to start? I want to look on the back to see if we have any holes blown through any ICs. I don't see a hole in DAP-053 anyway. Nothing obvious. Just a blown fuse. Just a blown fuse. Continuity mode. How is our fuse? Blown. Okay. Well, that was easy. Unless we have a short. Let me go to voltage mode right quick like. I have not discharged these capacitors, so I'm going to see if there's any voltage across these things, which I kind of doubt it because the fuse is blown and they should have discharged by now. Yeah, there's nothing there. Nothing there. So do we have a short? Say, like right across one of these capacitors. No. Okay, that's surprising. Still in continuity mode here. I want to check, like there's no short on the output. Nope. Nope, just charging up that whole row of capacitors there. How about these MOSFETs here? Nothing. Nothing. So I'm sure that if this fusor resistor is still good, and it is, I think we just have a blown fuse. Yeah. If the bridge was shorted, I would see it across this capacitor here. And I don't see it. So, well, that's easy. Assuming I have some fuses. I think I do, but I'm almost out. Almost. Well, maybe not. Maybe I ordered some and forgot about it. T8. T8AH, 250 volts. Okay, let's get that swapped out. Yeah. And I do have a desoldering gun back there, but if I'm just desoldering these 2 points, I'm not going to crawl under my desk to plug it in and all that kind of stuff. Get my fan going. Is it going to be that simple? Get my legs bent about right. Didn't quite clear that other hole there. Try it again. There we go. Okay. Fuse replaced. Let me clean up some of that flux a little. Did our DAP-053 survive? And some of the MOSFETs, there are several MOSFETs that are, real close to this AC line going in. That sometimes get popped. I need to add a little solder to this wire, the input AC wire. I took too much off when I was desoldering the fuse. Okay. See if we can wake up the DC load. We'll just give this a quick check. Negative, positive. Got an AC cord in here, which is switched off right now. So she's not going to start up. Load is set at 8 amps. I'm going to turn that on. And I think we're ready to check this. Maybe we'll bring it up slow. Load is on back there. This is off. I'm going to dial it down. Bring it up kind of slow here. Whoa, 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 whoa. We have a short. Yeah. That voltage is not coming up. And I heard the transformer in here humming. We have a short of some kind. Okay. Where? I did not measure a short. But whenever I start turning up that voltage and I hear that transformer, there's an variable isolation transformer inside that supply. When it starts buzzing, it's time to pay attention. Let me just get that cord out of the way. So my meter will lay somewhat flat. All right, back in continuity mode. Do I measure a short just like right here? No. No short. It sure didn't want to. Maybe it was coming up. No short. How about the power factor correction MOSFET? 10 ohms. That doesn't look right. 10 ohms. Dead short. Okay. Well, that makes sense. That makes sense. Power factor correction MOSFET is shorted. What about the diode next to it? Oh. Okay. No, it's just some capacitor or some charge going on there. We're not shorted. Just our MOSFET. Okay. I think I do have some of these. I should. Okay. Well, that's why we bring it up slowly so we don't waste a fuse. Let me hunt down this PFC MOSFET. All right, and this, let me show you this, if I can get it to show. This MOSFET for the power factor corrector is a 40N60M2, which I do seem to have some. Looks like I've used a few of them, but there's the part number. So let's get that changed out. All right, so our power factor correction transistor has been replaced. Let's see if we've done any good. Well, maybe it won't blow the fuse. All right, load is on, we're connected. I'm gonna bring this up slowly. If I can get that to focus some. Yeah, we're not humming, buzzing already at this point, so that's encouraging. Nope. Nope. We have a short. Still have a short somewhere. It tried to start, but we still got a short somewhere. I looked around the DAP-053. I didn't see any shorts around it. It could be damaged because that power factor correction transistor is connected, almost straight to it. There's a little bit of isolation with some resistors, but that didn't look good. I don't think she's working. Let's try what happens if I turn this load down like 2 amps. Oops, try that again. Just kind of curious. Nope. Nope. She's trying to start though, but she is very unhappy about something. Okay, we got more to find. All right, I was just doing some testing off camera, and I can show you. There's the voltage across our filter cap. It's bleeding down. It was over 500 volts. Yeah, and it's bleeding off slowly. They're only rated at 450. And if we look, I believe this one right here has got a little bit of a bulge going on the tip of it there. This one doesn't. So, yeah, our PFC boosted voltage is going way higher than it should. Should be about 395. And we went over 500 volts. So, either, well, we definitely have a capacitor we need to replace. But why is it going that high? That DAP-053 is the PFC controller. So either it has failed and or the feedback resistors for it have failed. This thing is charged right now, so I'm not going to be handling it a whole lot. Get something to point with here. But where are those resistors? Kind of hard to spot. I think I see them right in here. Let me get the camera over that way. Maybe I can zoom in. Yeah. Those two 10 megs right there are involved with it. They look pretty healthy though. But if they're not bad, then it pretty much has to be the IC. It's calling for that PFC voltage to just go higher and higher and higher. So although I did check, I didn't see any, shorts, odd readings around this chip. It could still be bad. So I need to change that out. See if we get our PFC voltage under control. All right, I just realized a mistake I made earlier. I need to correct that. I gave some bad information. The resistors that I was pointing out right here, these two 10 megohms, those are not the ones I was concerned about. These are is part of a divider for monitoring the mains voltage, the AC mains coming in. The ones I was concerned about that are part of the feedback circuit for the boosted voltage, the 395 volts DC. Those resistors are over there. 7.5. See those two 7.5 megohms right there. Those two, and as you can see, right there's the positive side of one of the filter caps right there. So two 7.5 megohm resistors in series. We come over here, and we go through a 75 k ohm, and then we come around over here, and we go through. There's a 10 k ohm to ground, a capacitor. There's a Zener to limit it. I think it's 8.2 volts, and we go into pin 2. That's the path I was concerned about. But the resistors look. Sometimes if they've taken lightning damage, they'll have a crack in them. There'll be a crack. I think these are okay. These are very hard. If I can get them in focus. These are very hard to check in circuit, by the way, because there's such a high resistance. So I've always had to, lift one end of them, slide them to the side, lift one end of it, and then you can kind of get a check on them. But they look good. I do have some of these. We need to change them out. But right now, I think I'm just going to go with changing out this DAP-053 because we know it took a hit. I mean, we know the power factor corrector IC, which that drives, that power factor corrector is right there. That's the MOSFET for driving the PFC circuit, and it is driven from this IC right here. And we know it was shorted up there, so yeah, let's go ahead and replace this. All right, so we have replaced the DAP-053. It's over there. We've replaced this filter capacitor that was bulging. So let's try this thing again and see if we're getting something more reasonable across these capacitors right here. And maybe some output. I do have the load set back there, but it is only like 2 amps, so not a major load. So let's give it some AC voltage. I'm going to start bringing it up slowly here. Let's see what happens. Make sure we don't run away. We started 9.6 volts out though, and run a little bit low on the boost voltage as well. What if I turn the load off? This seems kind of nervous. That just seems wrong back there, 9.6 volts. So we're running, but we're not right. So we have another problem. Turn that off. We have another problem. All right, so we are on the hunt for a strange problem here. Our voltage is low, and I think it's going to be something that is broken down. It's not going to be a nice convenient short. So what I've done is I've placed a working board here with the check mark right beside our broken board. And I've been making some comparisons. I'm just going to kind of go over some of that with you. Be easier to see under the microscope. So let me get set up. We'll just do that. I am looking, let's see, on our broken board, right over here by these opto isolators. I can get everything in the shot there. This is the area we're working in. This is the hot side of the board, so I'm going to put my red probe on the negative terminal of one of these big filter capacitors back here. And we're in diode mode. And if we look around this transistor here, which is a small MOSFET, right here, got a reading of 1.24. Okay, keep that in mind. And if I go to our working board, That exact same point. Where were we? Right in there. Do the exact same measurement. Red probe on the negative terminal of the large filter capacitor. Right there. We get open line. So something has broken down on that line, and I think it's going to be the transistor, the MOSFET, which that W4R is a 2N7002 MOSFET is what it is. And I'm pretty sure I've had those fail before. So let's just real quickly crank up the solder. Let's lift a leg of that MOSFET and see if that goes away. There are some other things on that line. There's some Zehners on the other side, you know, further over on the, well, toward the AC input side of the board, there's some Zehners over there, which may be involved, but I got to find out. This is just kind of, in my memory, I think I've had this problem related to this transistor right here. So let's start there. See if we can just lift a leg. Without destroying it. I might just remove the whole thing. This might be easier than just lifting one leg. I always, which I have these, it's not a big deal, but I'd rather not break it. But as you can see, the legs are rather short, and so they don't have a lot of range of motion to them. There, that one's up. And I'll lift this side too, just for the heck of it. Now this, of course, this transistor is glued down, so I can't just pop it right up without desoldering every leg of it. Anyway, is this one up? I believe that's clear. All right, let's see what we have now. Red probe on that ground, the common. Right here. Open in here. Yeah, 1.2. So, as we suspected, this little transistor is bad. Let's see if we can get it off there and get it replaced. Let's see, is it ready to pop off there? If I can get under it. Shouldn't be much left holding it on, except for the glue. This is too big of a soldering iron for this, but whatever. It's what I had in my hand. Alright, get rid of you. Add you to the pile of broken parts. Look overhead. Grab my tray. Yeah, I've used, yeah. Looks like I've used quite a few of these. So, of course, there are several of them on this board. These are available from Mauser. And they are really, really cheap. So I bought a roll of 100 of them. Now, find my small caliber solder. Oh, come on. Don't go crooked on me. I can't leave you like that. Still a little crooked. I can leave you like that. Alright, and I may double check that reading. I think we're good. Yep, still open line. Over here we have, that's ground, and this is 0.6. I think that's good. I think that's normal. Alright, let's get set up for a test. All right, I think I'm set up to check this. I'm still metering across the filter, the bulk filter capacitors there. I have the load connected. AC line is connected, but it's turned off. There's the transistor I replaced, if I can get that to focus, if you're interested. That's the W4R transistor. Let's see now. A lot of glare on that. I'm going to wind this down. We're going to bring it up slowly. See what happens. I'll get where you can see all these meters. Hey, there we go. Winding it up to 120 volts AC there. That looks much better. Running about 395 on the boost voltage. 12 volts back there. Only drawing 2 amps of current. We can ramp that up a fair amount. 8 amps. Yeah. That loaded my voltage down a little. You can see we can switch to current. So we're drawing a little less than an amp. So that looks much encouraging. Okay. I think we are good. I think we're ready to put this back together and give it a test in the housing and finish this one up. All right, well, this PS5 is reassembled with our repaired supply, and we replaced that encoder IC. I did touch up the legs on the HDMI port. It was an original port, and they're kind of weak. They don't really have enough solder on the pin, so I did touch that up. And as I turned it on, I heard the drive spin up. So let's see what we have in the drive as a bonus. Okay, Madden 22. I already have one of those, but oh well, I'll take it. And also, I did check and notice this console's on firmware 5.1 or something, like 5.0, something like that. So I'll probably won't be updating it. But anyway, hope you liked that one. Thought it was so interesting, educational, entertaining, any of the above. If you did, please let me know with a thumbs up, and I'll see you in that very next repair. Bye for now.